I was thinking about this, and since I had to get up and let my dog outside, I thought I would test this theory. And what I did was I made this a 5.5 inch structural ridge by, I think I went to here, build framing. Yeah, I made this the ridge 5.5, but there's nowhere in here for the hips. So I left it alone. And then when I built framing, it made the ridge and the hips both 5.5. And, I've done structural ridges before, but I've never done 5.5 hips. Typically, these would be 3.5. So, or whatever, let's say they'd be LVL 1.75. Whatever. It doesn't really matter, because here's the problem. Then I tell it to go ahead and build framing and build roof framing. And it reads the ridge that I put in manually at 5.5, and it makes all the hips 5.5. So that's wrong. And then this really points out the mistake here. This, whatever this rafter length is at a run of 9'9 1/4, needs to be the same length as this end common over here. That way the ridge would pull over here. But they're following this invisible center line. And so also the reason why the construction master and the build calc and everything are not accurate, especially with jacks, is they don't allow the variable of the thickness of material. When you punch in those numbers, it's just taking the assumption that, okay, you're going to find the run. Whatever the thickness of the ridge is, you're going to take the span minus that thickness divided by 2. And then from there, they're making all their calculations. And that doesn't always work. If you had a ridge that was too thick and a hip that was not as thick, or the other way around, let's say you had just a standard 1.5 or 1.75 ridge, and you had really thick or thin hips, there's nowhere in those calculators where you can enter that information so that it can have that to include in the calculations. And that's the only reason that it's off. It's not by much, and most people say close enough, but it's not exact either. So what they need is to allow for the, like the RPN that I wrote for my scientific calculator. I had it ask questions. It prompted me. And that's, one of the questions would be ridge thickness, hip thickness, those kind of questions, just so that it has that extra little bit of information so it can do a more accurate calculation. So like these here, let's figure out what this is here. Hopefully it'll let me snap. That's the other thing is, it wants to snap to the center of this jack. Let's just see what this experiment does for us. I'm not even getting, see that there? That's that's not right. I wonder why it's not letting me snap to the intersection. I'm going to make best guess right there. All right. We'll go ahead and say that that's accurate, even though it's not. Then we're going to turn on label, specify label. Okay. All right, so Chief is saying that this jack is this long to the outside wall. We're going to bust out our handy dandy Construction Master desktop version. Oh, yeah, it's early. Hold on. You can hear the birds outside. It's kind of cool. What is it? It's 4:36 in the morning. Run, 8-inch pitch, diagonal, 10 foot 1 1/4. So that's what it should be. It should be 10 foot 1 1/4. Anytime you dimension in 2D like this, your dimensions are horizontal when you do the manual dimension. And then this number that's part of the rafter that comes from the macro that Renee made is measuring something along the angle. What's really amazing is it's showing that there's a square grip at both ends, but that's not the length. Let's see. And I don't know. See these snap points? I don't know where they're coming from. Yeah, I don't know what's going on here. But anyways, I just know that it's not right. And the way that I originally found out how this works is when I had AutoCAD and I manually drew everything. And that's another design secret if you want to be accurate. Draw everything to the exact size that it is. 1.5 inch thick material. Spacing 16-inch on center. Let's just check that. See if Chief's doing that right. It should be. Yep. But I used AutoCAD because this is way before Chief was a thing. And I would draw these things out in 2D exactly like I'm looking down on them from the sky. And then with those horizontal measurements, you can measure all of this horizontally and then run each one of those horizontal measurements through a calculator, like a Construction Master, and get the actual along the slope diagonal length of whatever it is you're looking for. Like this right here. This is not correct. That's 15 inches. And over this is 16 inches. That's how Chief wants to do it. Totally cool. That's what you want to do. But if you were framing this building, all your framing is what matters, because you can change the fascia trim. You can change, like, you don't measure over the sheathing on a wall. You're going to cut your bird's mouth to fit that, but that sheathing could change. You know, you could change from 1/2 inch sheathing to the new zip insulated R series. So those are all different variables that can change, but the framing's never going to change. So that's why all dimensions are over face of framing. So anyways, if you get out a CAD program, and you can see how difficult it is to get a good snap point, because if you zoom in, look at that. I'm not quite right. See that? But I mean, that's minimal. But in a CAD program, it should snap to those things automatically. I can show you really quick in AutoCAD. It'll do that. It'll snap to, well, AutoCAD's not as intelligent as Chief. This is an object in Chief's world. This actually ends up in a material list. In AutoCAD, it's just a line. It doesn't mean anything to anybody. But on the flip side, I can measure that line. Let's do this. Let's just go here. And here's another reason. I'm going to show you why it's important to be this accurate. So this project out in Squim is going to have 3 rake walls. And what I like to do is fully dimension these things so that, because here's the thing. Most framers are going to pop this out on the ground, and then they're going to measure the lengths of the things that they popped out on the ground. and then cut them and put them together. And I don't like to bend over that much. It's not how I enjoy my life. So what I do, I'm going to have to make these a lot smaller. But as you can see, this is what I do. I measure. So you can take this full board layout. You can lay out where the long points of your studs land. And then you just dimension the same thing on this bottom plate. And once you have the plates marked correctly and all the studs cut correctly, this thing goes together and it's exact. And cut these, go ahead and free cut them with a skill saw if you're good, or if you got somebody who's got a chop saw set up, you can cut them at this bevel right here on this side, which is a 3 and 12. And then over here, we had to change this pitch because it had to land on this wall at a certain distance. So this side's going to be a little bit different than the other side. Here you go, 15.02. So that's why trying to hit exact will benefit you on the job site. Same thing, rake walls, roof, whatever. Close enough doesn't work. If you try to close enough this, you're just going to be fighting. I don't know. You know, you'll get it done. The windows will work. People cover it with sheetrock. Redneck framers will say, can't see it from my house. But there's nothing wrong with using a little technology, especially the day before, a couple days ahead. Work out all the bugs, and then come to the job site with a laminated cut sheet and make it work. And all it takes is, if it's your job, make sure that you hit the spans you're supposed to hit and the elevation. Like this wall is a custom height wall. There's a lot of things going on in this little project that are very custom. And if you fully understand them, then when you show up on the job site, you don't have to do job site thinking, because job site thinking is expensive. You have people waiting on you. You're under distracted pressure. So if you miss something or if you fat finger something, I've just found that letting her rip on the job site isn't how I want to do it. I want to come to the job site and know what I'm going to do. It's already been thought out. But everybody gets to run their own business the way they like. So if you like to be on fire at work, hey man, go for it. All right. Well, I'm going to try to go back to bed now. So y'all have a good day.